Hi students, I welcome you all in the 8th lecture of TOC, and I hope you have learning many things from the lectures, and similarly you should start reading the books because reading book will give another confidence while solving the questions. Okay, uh, and one more thing that maybe we will miss many things, but books will help you to recollect that things, and you can ask us also, please record the video on this topic is not covered that much. So that's why I'm suggesting you to go through the books. That will definitely help you. Okay. So in last lecture we have completed till in that we have covered basically the conversion of CFG into CNF and CFG into the GNF form. Okay, so in this lecture we are going to see the machine we need to accept the context free languages. Previously we have already seen that for accepting the regular languages we are having the machine called as finite automata, but uh, in terms of accepting the languages like context free languages, these languages are not accepted by finite automata because for accepting such type of languages we require some memory, and finite automata don't remember anything, means it is not having any memory. Suppose we can say that if we will ask finite automata how many A's you have read till now, then finite automata will not answer it because it is not having a memory, it is just reading. Okay, so for accepting such type of languages which requires memory, we will go to the another finite automata and we will see which is that finite automata and how that finite automata will work for accepting the languages like context free languages. Okay, so let's see that. So for accepting context free languages we have an automata called as push down automata. Okay, and this automata is having an finite memory. Okay, so we can also call it, we can say like this: PDA is nothing but finite automata plus some memory, plus some finite memory. Okay, so this memory here we are using stack. Okay, so we can say that PDA is nothing but finite automata plus stack. Okay, so in earlier we have seen the definitions of we can say that DFA, NFA and epsilon NFA in terms of the tuples. Okay, so similarly in this also we are seeing, we are going to see the definition of push down automata in terms of tuples. Okay, so basically it consists of 7 tuples. Okay, so which are they? Q, summation, delta, Q naught, then Z naught, F, and this is tau. Okay, so these are the tuples, and here we have 2 extra tuples than DFA, that is first is Z naught and next is tau. Okay, so let's discuss what is mean by Q. Okay, so Q is nothing but set of finite states. Okay, we have finite number of states that is represented by Q. Summation is nothing but input alphabets. Input. Delta is transition function. This we will discuss mainly in terms of deterministic PDA and non-deterministic PDA just after this. Okay, Q naught is nothing but a starting state. Z naught is a bottom of the stack. जो सिंबल बॉटम में रहेगा स्टैक के वो Z naught रहेगा बॉटम ऑफ द स्टैक. F is nothing but set of final states. Okay, here I am using set of final state, means we can say that we are having one or more final states. So basically these more number of final states will arrived while discussing non-deterministic PDA, and tau is nothing but stack alphabet. Okay, so I can say that basically जो भी हमारा PDA है वो जो हम डिस्कस करने जा रहे हैं, it is divided into two parts. One is deterministic PDA and other is called as non-deterministic PDA. So we will discuss about these two PDAs throughout this lecture or throughout the lectures, and also PDA is categorized, just give me a second, PDA is categorized based on their acceptance into two categories. Okay, so PDA again is categorized based on the acceptance. Which are they? So it can be accepted through final state, or we can say that empty stack. Okay, both are the correct ways. We can use any way. If the in question it is not asked whether you have to solve by using final state or empty stack, we can choose anyone. Okay, so we will see one example by we can solve one example by both the approaches, and after that we will use one approach only. Okay, so basically here we have discussed the definition of PDA, then we have discussed the type of PDAs available, and again we have divided the PDA by their acceptance. So it can be accepted by final state or empty stack. Now we will discuss this transition function. Basically we have to focus on this transition function based on whether it is a DPDA or NPDA, that is deterministic PDA or non-deterministic PDA. Okay, so let's see about that. So basically in DPDA the transition function will look like this. DPDA, so transition function is defined by using delta, so it will become q into summation or epsilon, then it will, or just a second, and again we have stack alphabet, then after that it will give us q into tau star. Okay, so basically I will explain this in detail. So let's consider I have the input like this a, b, okay, after that anything, and finally we have the epsilon. Okay, so remember one thing, in PDA every string is ending with epsilon only. Okay, so suppose they have given us a, b, a as a string, then after that at the end we will use epsilon there. Okay, so in every string we will use this epsilon, so finally I am using epsilon, and I have finite automata. Okay, finite automata with some memory, so I am using, this is the memory, and this is the stack, and this is the bottom of the stack. Okay, now I will discuss this. Suppose I am in particular state q. Okay, so finite automata I have designed and I am in particular state q. Next, after reading an input alphabet, where is the input? This is the input. Okay, so after reading an input alphabet and along with stack alphabet, okay, suppose I am here and I am reading this stack alphabet. Okay, so again I will tell you what is this. Suppose I am in particular state q, here I am in particular state q, and along with that I am reading the input symbol from the input, whether it is input alphabet or it can be epsilon, and along with that I am also reading the stack alphabet, and after that I am going to change my state, or and I will update the stack alphabet. Okay, so here I am writing the star because the stack alphabet may be 1, 2 or many. Okay, so that not be always one, we can update to stack alphabet also. Okay, so basically this is the explanation of DPDA, transition function. Finally I will read once again this. Suppose we are in particular state queue, and after seeing an input alphabet along with the top of the stack or stack alphabet, after that we are going to change our state, or we will stay in particular state and we will update the stack alphabet. Okay, whether it is we have to push or pop. Okay, that's depend on the example. Similarly, we have the transition function in terms of NPDA. So this transition function will look like DFA only, just because it is having the memory, and it will look like NFA, that is non-deterministic finite automata. Let's say that. So it will be represented by delta, and suppose I am in particular state Q. After seeing an input alphabet or epsilon along with stack alphabet, then I will go into 2 raised to power Q into, and I will update these many stack alphabets. Okay, so this is the transition function with respect to non-deterministic PD. Okay, I hope ये समझ में आ गया होगा. So we have discussed till now definition of PDA and its acceptance. Will be better understand while solving the example, and also we have discussed the transition function with respect to DPDA and NPDA. Now let's take one example and we will see why we need an PDA where the finite automata fails. Okay, so all these things we will discuss in that particular example. Also we will discuss what is mean by string accept and language accept, and what we need, whether we need a string accept or language accept. Let's see. So the question is that we have to design a PDA for the language 0 to the power n, 1 to the power n, where n is greater than or equal to 1. So first we will write down the language and what are the strings possible over this language. So I will write L is equal to, so language becomes 0 to the power n, 1 to the power n when n is greater than or equal to 1. So first language that should be generated from this language, first string, so that minimum length string becomes 0 1, then after that 0 0 1 1 triple 0 triple 1, 4 times 0 4 times 1. Okay, so this should be infinite number of strings. Okay, so language is infinite and this contain infinite number of strings. So first of all we will discuss whether we can able to design the finite automata, whether it is DFA or NFA. Okay, let's try to design that for this particular language. So if I will start to designing, I will try to accept very first language, that is 0 1. Okay, so I will write here 0. Okay, and after that 1, this is the minimum finite automata possible. So by using this finite automata, whatever the strings contains in the language, all will be accepted. See, 0 1 0 1 is accepted, 0 0 1 1 0 0 1 1 is accepted, triple 0 triple 1 triple 0 triple 1 is also accepted, and 4 times 0 4 times 1 also accepted. But it is having one problem. Okay, so let's design another one, and after that we will discuss the problem in this. And basically this is the DFA only, because we have the transition for both the alphabet. Similarly, I will try to design in another way. Suppose this is the A state, and here I am accepting all the zeros. Whenever one comes, I will change the state and I will accept here ones. B is the any number of ones. Okay, so here this finite automata also accept all the strings present in the language. Now that's why I am uh, told you that we are going to discuss two things, that is, first is string accept and other is language accept. What is meant by string accept? It will accept all the strings present in the language. So this is the condition. Okay, now check whether we can say this finite automata is string accept or not. Okay, so let's check. We have already checked all the strings present in the language are accepted by this finite automata. So we can say that this finite automata is string accept finite automata for this particular language. Similarly, this finite automata, ओके सो दिस इज जीरो के लिए ट्रांजेक्शन है, वन के लिए ट्रांजेक्शन है, यहाँ पे वन के लिए, यहाँ पे जीरो के लिए नहीं दिया है. सो आई एम कॉलिंग इट एज ए NFA. इन NFA it is possible. Okay, so this finite automata is also a string accept because it will accept all the strings present in the language. Okay, now we can say that okay, it is accepting all the language, all the strings. Then why we can say that this language is not accepted by finite automata. Okay, so let's discuss now what is meant by language accept. So similarly, in this also having the condition, it should accept all the strings present in the language, and यहाँ पे क्या है, दूसरी एक कंडीशन है, and also it should reject all other strings which are not present in the language. Okay, means ये क्या कह रहा है कि it should accept all the strings in the language, और यहाँ पे क्या हो रहा है, सारे strings accept कर रहा है finite automata, but also क्या होना चाहिए, it should reject, compulsory it should reject all other strings which are not present in the language. Suppose in this language this string is not generated, that is 0 1 0, this string is not possible, but if we will check, this string is also accepted by this finite automata. Okay, so देखते हैं 0 okay possible, 1 possible, 0 possible, it is accepted, it is showing accepted. And in this automata also this string is accepted by 0 1 and then 0. Sorry, for 0 के लिए transaction नहीं है, तो there it can go to the forever state. Okay, but if I will add here 0, then it is accepted by this finite automata. So that's why we are not focusing on the string accept finite automata, we need an language accept finite automata. Okay, means क्या होना चाहिए कि it should accept all the strings present in the language. Similarly, it should reject all other strings which are not present in the language. Okay, so that's why you can say that for designing finite automata for such type of languages is not possible. So that's why we came across push down automata, because in that case we need an memory, because we have to count that how many number of zeros came till now, and after that how many number of ones came. Whether that is equal, then only we will allow, otherwise we will reject, or we can say that particular language will not be accepted by PDA. Okay, so let's see the working of PDA. We will solve this example using the push down automata. In this we have to build a logic, because we have one PDA, that is, sorry, one stack. So by using one stack we have to solve this example. So the logic is, basically we have the language. I will write language here: 0 1 0 0 1 1 triple 0 triple 1, many other strings like this. Okay, so basically we can see that here once 0 is over, then after that 1 start occurring, and we have to match whether zeros and ones are equal, then only we will accept. Means for this 0 this one is there, 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 and finally for this 0 this one is there. Means we have to compare 0 and 1. So basically we have the stack. So what we will do, we will build a logic like this. Whenever 0 comes we will push. Okay, whenever 0 comes we will push in the stack, and once one started occurring we will start popping. Okay, we will change the state and we will start popping. While solving example I will tell you why we need to change the state. Okay, so let's take one example, that is one string. Suppose I am taking one string as 0 0 1 1. This is the string, and after the end of the string I will add the epsilon. So this is the epsilon, and similarly I will take the stack, and bottom of the stack becomes z0. My pointer is pointing here. Now input pointer is pointing here, and initially I am in q0 state. Okay, q0 is a initial state. So here I can say that 0 is there, and top of the stack kya hai? Z0, or we can say that bottom of the stack. Okay, so 0 is there as input, and top of the stack is Z0, or bottom of the stack, we can say anything for this now. So I will update into the stack. Okay, means I will push into the stack. Easily we can say that when we are asking about input, this is input and this is the bottom of the stack. So whenever input comes and bottom of the stack is there, so we will pull out that Z0, we will hold it, and once we reading the string, after that we will decide what to do with this. Okay, so now after that what we have decided, we have to push 0 Z0. So I have pushed. Now in stack nothing is there, because Z0 I pulled out from the stack. Now what I will do, I will push 0 Z0 into the stack. Okay, and top of the stack becomes this 0. Okay, now I will change, I will shift here, because this input is red. Okay, now next input is 0 and top of the stack becomes 0. So what to do, when 0 is there and top of the stack is also 0, I will pull out this 0, and again 0 is there. So whenever 0 is come, I have to add 0 0. So this is become 0 0, and I will push that 0 0 into the stack. This is first 0 and this is second 0. Now my top of the stack becomes this. Okay, understood. And next 1 occur हो गया, क्या हो गया, 1 occur हो गया. Now input is 1 and top of the stack is 0. Now I need to change the state. Why? Suppose let's consider I am not changing the state and I am writing here only. Okay, so यहाँ पे अगर मैं लिखता हूँ तो क्या आएगा, this is become 1 input and top of the stack is 0 and here epsilon is there. Understood? So string now I am reading is like this: 0 0 1 and epsilon is there. because I have to pop, so I pop this 0, consider this. Okay, now top of the stack becomes 0, and after that suppose again 1 0 came, so I am reading from here. So 0 is the input and top of the stack becomes 0. So my logic is what? Whenever 0 comes and top of the stack is 0, I will add it. So I have added this 0. The problem क्या हो जाएगा? After that, if two ones came, this string will also be accepted by particular PDA, and this should not be done because we have to accept 0 to the power n and 1 to the power n. Okay, so that's why we will going to change the state. So that's why for this transition I am changing the state, that is 0 is there. Sorry, first I have to write the input. So input is 1 and top of the stack becomes 0, then I will pop. So top of the stack is 0, so I have popped and I have updated my top. Now again I have occurred what? 1 is there, so again top of the stack I will check whether that is 1 or 0. So here 0 is there. Whenever input is 1 and top of the stack is 0, again I will pop it. ओके, सो ये जितने टाइम्स क्या होगा 1 ऑकर होगा और यहाँ पे 0 रहेगा, तो देन आई एम गोइंग टू पॉप. And after that, once all the string is over, we will check whether at the last we are left with epsilon. This 0 is also popped by using this, and if the top of the stack becomes z0 now, then we will say that this string is accepted by our PDA. So epsilon is there and top of the stack is z0, I will make it as it is, that is z0, and I will go to the final state, that is QF, and I can say that the particular string is accepted by this PDA. So we can say that this PDA is for the language 0 to the power n, 1 to the power n, where n is greater than or equal to 1. Now here we have accepted the string by using finite state, so this is become acceptance by final state. Okay, suppose we have to write the transition functions with respect to this. So how we will write? So the transition functions, suppose we are initially in Q0, okay, Q0, and after seeing an input 0 and top of the stack is Z0, तो हमने क्या किया था? We have moved to the Q0 state and we have updated the stack as AZ0. Similarly, delta, that is transition function Q0, when input is 0 and top of the stack is 0, then we have stayed in that state only Q0 and we have updated, this is 0, so this is 0 0. Again, when we are in Q0 and we have seen 1 as input and top of the stack is become 0, then what we have done? We have moved to the Q1 state and we have popped it, that is the stack. Stack पे क्या किया हमने? Pop किया. Next, in Q1, suppose we are in Q1, here Q1, and after seeing an input as 1 and top of the stack is 0, then also we have stayed in that state and we have done the pop operation. And finally, when we are in Q1 and we have seen the input as epsilon and top of the stack becomes Z0, then we have moved to the QF state and we left Z0 as it is. Okay, Z0 is as it is. Okay, so this is become acceptance by final state. Now we will design the same PDA for acceptance by empty stack. Okay, means what is mean by empty stack? We will not put that Z0 also in the stack. So first of all, I will design the PDA for this. So Q0, suppose I am in Q0, okay, the remaining operations will be like this only. So 0 input है and top of the stack अगर z naught है तो I will update at 0 z naught. Similarly 0 input है and top of the stack भी 0 है तो then I will update it 0 0. Similarly if 1 occur हो गया तो हम क्या करेंगे, 1 occur हो गया, top of the stack 0 है तो then we will pop that and we went to the Q1 state and Q1 स्टेट पे है हम, और वहाँ पे भी सेम अगर ऐसा होता है कि 1 इनपुट है एंड टॉप ऑफ द स्टैक 0 है देन वी विल डू पॉपिंग ओनली. एंड फाइनली यहाँ पे क्या हुआ था, हमने यहाँ पे एट द एंड वी गॉट 0 0 1 1. एट द एंड वी लेफ्ट विथ एप्सिलॉन एंड टॉप ऑफ द स्टैक इज z naught. What we have done, we went to the final state and we have accepted that. But in this acceptance by empty stack, what we will do, we will stay in this state only. And what we will do, suppose epsilon is the input and top of the stack is z naught, then we will pop that z naught, so this z naught will not be there. So finally we can say that stack will be like this only, nothing is there in the stack. So this is the acceptance by empty stack. Okay, so the transition functions for this will be same. This function should be same, this function should be same, this function, all these 4 functions become same. Only difference in the last function, that is when I am in Q1 and after seeing an input alphabet as epsilon and top of the stack becomes z naught, what I will do, I will stay here, I will write or, I will stay in that particular state, that is Q1, this is QVF, okay, Q1, and what I will do, I will do the pop operation. So this is nothing but acceptance by empty stack and this is nothing but acceptance by final state. Okay, so now onwards what we will do, we will solve all the remaining examples by acceptance by final state. Okay, so you can easily derive or you can easily design the acceptance by empty stack. Okay, I hope आप लोगों को ये समझ में आ गया होगा. And if you have any query then please ask in the Telegram group or you can post a comment on the video, so I will answer that query or answer your query there itself. Okay, thank you so much. We'll see in the next lecture.